Awesome, thank you. All right, let me tell you a little bit about Ryan. Ryan Stevens leads core risk and growth teams at Ramp, building the ML models that power their platform. He's sharing from noisy alerts to smart fixes, AI and incident response, how they build AI systems that parse logs and suggest fixes, turning that 3 a.m. panic into manageable problem solving. Once again, welcome, Ryan.
Oh, yeah. Is that too loud? Are we good? All right. Well, yeah, excited to be here. Yeah, I'm Director of Applied Sciences at Ramp. Just for a little bit of background, Ramp is a business-to-business expense management solution. We have corporate cards, bill pay, travel, reimbursements. We're building AI to save companies time and money. And so you always have to start with a meme, right? This is a common sort of thing we see in the industry, and you might even see internally. Someone might say we're building an AI worker, an AI salesperson, an AI on-call agent. And then what's being ignored is, we're just trying to automate some boring stuff. And I think that's kind of the important thing. Boring tasks is really where a lot of the value is. And so what this talk is going to focus on is I'm going to set up a framework around tasks. There's a lot of things you could work on a company. You could try to do many things. But what is AI agents actually good at? I'm going to kind of set up a framework of how you can prioritize. Then I'm going to apply that to talking about analytics engineering on-call. I'll describe what an analytics engineer is to this room because it might not be familiar to everyone here. And then I'll talk about the build, what we built, what we learned, what we did. Cool. So I'm an economist by training. And so I obviously have to quote economists. This is a recent survey of businesses that was published in Economic Letters asking, what is AI doing to your company? And what AI is doing is it's automating tasks, not jobs, currently. Who knows what 5 years is going to be? So 27% of firms, it's automated some tasks, but only 5% has it replaced jobs. Now, what is a task and what is a job? You have to have some criteria to distinguish them. And I think it's these three: scope, orientation, success criteria. Scope. If we think about it like a math problem, you have to bound it. There has to be a bounded search space that you can actually go through. Orientation. There has to be a goal. There has to be something you can point at. There's a direction that the agent is going. Success. I think this is something that everyone in this room today, almost every speaker, has talked about. You have to be able to measure it. It has to be precise. It can't be ambiguous. Jobs are ambiguous. Have you ever had a performance review? Yeah, so that's sort of, agents handle tasks well. They don't handle jobs well. And so I have this little picture, and this little picture is sort of like hill climbing exercise if you viewed it from the top. Someone is kind of searching this space. They have the first guess, they go to a second guess, a third guess, and a fourth guess. And accuracy changes. There's some metric here. And so you can see second guess, it improves. Third guess, it gets worse. So they go to the correct guess. And this little picture here is what I mean by these three little ideas. Scope, it's a bounded search space. This is a circle. It's not everything. Orientation, it can go somewhere. It knows how to point itself. And success, it figures out when it gets there. It can measure itself along the way. And sort of what does this framework give us? It's something that I think has been mentioned many times here. It gives you feedback loops. So tasks give you feedback loops, give you performant agents. So generate some output, measure it, or the fancy new term eval. I have thoughts about this term. Yeah, okay. And then with those evals, you can refine your inputs, the prompts, the model, the context, the schemas, the system, and then you can do the whole thing again. Now, the funny thing about this picture, which you'll actually see in a lot of AI talks, is this isn't a new picture. This is a 40-year-old picture at this point, thinking about predictive systems. AI has literally reinvented this wheel. And that's kind of the ironic thing. Anyone that's done ML, anyone that's built a statistical model, this is how you think about the problem. So let's take a use case, take the framework, figure out what we think AI is going to be good for. So analytics engineering. It is a new function that combines kind of a few different functions that used to exist. So people here, HelloFresh, do you know this company? A company like it. So this is the analogy we like to use. What does HelloFresh do? They will get some ingredients for you, they'll clean and prep them, they'll create a recipe for it, and they'll deliver to you that recipe and the ingredients. An analytics engineer is doing the same thing for data at a company. They are extracting the data from external systems. So this used to be the job of a data engineer. This area has been commoditized, and there's a lot of services and companies, Fivetran being one of them, that allows you to integrate with upstream sources and put them into your analytics warehouse. We use Snowflake, we love Snowflake. Yeah, great database. Then the analytics engineer will clean and prep it in dbt data build tool, which is just SQL with Jinja, is what people say it is. And then they'll create what's called a data mart. A data mart is the recipes. They're the core tables that companies will use in order to do analytics on top of. And then they'll put it somewhere for other people to use, maybe in a BI layer, or with documentation so that someone can come in and actually query it. So that's what an analytics engineer is. What is their on-call like? So really their on-call is just getting these extract, transform, load jobs, ETL. I think I said that right. Someone can correct me afterwards. I always get that wrong. Getting those ETL jobs finished, and then assisting with data investigations. So, this is sort of what we did when we came into the space, is we're like, what is the on-call supposed to do? And for context, why is this an important problem? Like, we have a data team now of upwards of 30 people. We have thousands of data models. Our on-call burden for a single individual is getting more and more over time. We're also going to talk about the use case here, which is alerting. People build tables. Tables become tech debt because alerts will trigger, and then you have to triage those. So it's an important area. It's one that's costing us internal productivity. It costs us time and money. And so what does the on-call do? They might debug some failing queries. They might investigate these data extraction issues with upstream sources. They could answer help questions for data. People are like, what does this data mean? Or like, how can you help me with this? And then they can do a coordination function, just like any on-call does. There's an incident, they talk back and forth. This is like a set of things that they could do. You have to figure out what are you actually gonna build an agent for at first. And so you wanna put it in the framework. You wanna put it from tasks to jobs. And so debug failing queries. There is like a scope to it. There's a criteria to it. There's an orientation to it. Coordinate with upstream and downstream people. I would challenge someone to figure out how you judge successful coordination at any company. And so we started here, and that's what I'm going to talk about, is how do you build an agent that helps with debugging failing queries. So this is the workflow that we had before. So dbt is great. dbt allows you to write tests on columns of data. So this is a return code of a payment. So if a payment fails, you get a return code. And that test basically says we always need that. That should never be null. And what happens if it's null? Well, we get a Slack alert. This is a Slack alert to me. I built this table. It is the bane of my existence. I built it maybe 4 years ago, and forever I will own this table. And there's a lot of rows. And then that's me trying to figure out what's going on, being mad that I still have to maintain this table. And so let's think about how it follows the task framework. It fits very nicely into it. It's actually a bounded problem, and it's bounded because all the LLM really needs to know is the DAG structure. So it needs to just know the upstream and downstream tables. That's here, actually, just the upstream tables. So the problematic one, and then it just needs to know everything upstream. And then it's actually contextualized in dbt for us. It's already in code. So it has a search space. It's pretty easy to point it at. It also has a tactical goal. How did I fix it? I fix it with a PR. I can be like, okay, your job is to fix it with a PR. It actually has a success criteria, right? There's a test. It's just a unit test. And so it really fits into this framework quite well. And sort of with that, we can build this, or we can think about building something like this. And it allows us to do a code gen, a very good, like conceivable code gen. An alert is generated, we investigate it with the agent, it creates new DBT code, it runs DBT, or it runs, compiles, and then like checks the output, and if it fails, it tries again. See, that loop is important. That's an internal loop for the LLM to validate itself. And like, to be totally honest, this like took a while to sort of convince people that like we shouldn't do this until we have this, and you have the tooling to do it, i.e. you have the right perms, it can run these queries, it can run them safely, it can do all of that stuff. That's actually like a lot of the, I guess, messiness that goes on here. But conceptually, it makes sense why you would start with this and why what I just told you says this loop exists and I can get an agent to do it. So this is like the first version. This is our first iteration. It's just focused on PR generation, code gen with a PR. So what does it do? Alert is generated. We have our alert agent. It has some prompt. It creates a PR, and that PR gets reviewed by a human. Some people like text slides. I sometimes do. If you just think about the swim lanes chart, we have DBT and Airflow that does this orchestration. It runs DBT. And then we have the alert agent that we use Metaflow. Love Metaflow. It's an orchestration framework, Pythonic. I have comments about Airflow that I don't think I should make publicly. I like Metaflow in isolation of coding in Airflow. Then we use small agents. I put that in there, not because we deeply thought about what agentic framework we should use, but actually because small agents is really easy to use. And in fact, that's like my lesson here is like, I do not actually like the agentic frameworks. Like the bigger ones, there's so much cruff, there's so much to learn, and you just want to get something out there. And most of the time we spent was on the system, the prompts, the context, keeping everything saved. And I wanted to think as little as possible about like orchestration of the LLM itself. And so that's actually why we use small agents. And I would actually recommend folks to start there if they're like, I want to use an agentic framework. And then obviously we have GitHub. So this is going to be an important section here. So code generation success like requires human review. So what does successful code gen look like? I think there's three sort of areas. There's syntactics. Does the code run? Obviously the agent can grade itself. It can run the code hopefully, but that was actually a fun time to try to give it snowflake perms and allow it to do it safely. But yes, it can run it. Like I said, the hardest part, especially at bigger places, at legacy places, is like making sure it has the right perms and making sure those perms are given safely. It can't leak secrets. Like this is actually a hard problem depending on where you are. So don't underestimate the time it'll take for that. But once it can do that, yes, it can grade itself. Semantics. LLM's not so good at this. They're not so good at grading their own architectural patterns. There's a way to write SQL. We have very specific standards that we use, and also how tables work. Yes, they can fit architecture. Yes, you can give them our SQL guide, which we do. We have like a syntax guide, and we have like a guide for things. But they don't optimize for maintainability. That's not what they're trying to do. And does the code truly solve the problem? An agent can only grade against the metric. And my metric here is test failure. It can't say it fixed the root cause of the problem. We have tables. Tables are connected to each other. The problem could be far upstream of it. And so CodeGen needs a human. And I think a lot of problems need a human. I think Hans talked about like getting humans to do stuff is hard, and it's like important, and human review is one of the important things here. And so my side quest is like getting humans to label your data for you is like so much harder than people think. And interfaces are so important. In fact, I never want to build a front-end interface for humans to review. So it's easy to get humans to label things once. You can always get resources. You can go do it yourself. It's really hard to get humans to continue to do things. Poor interfaces will crush you. And I think it's like one of the unsolved problems here. But we already have everything we need, and it's called code review. And we already have a nice interface, and it's called GitHub. They already exist. It's already part of people's job. It's an expectation of what they're supposed to do. And so one thing we did consider, by the way, was Slack messages. We're like, okay, the agent's going to give a summarization, an investigation, and then give it as a recommendation for the person that owns the table, myself in this case, to go review. How am I going to grade that? How am I going to collect data to determine was that a good recommendation? Now, what Slack has is it has submit review button. I can approve, I can request changes, I can leave comments, and I can use all of that to then try to be like, is the system actually doing what we want it to do, and how do we actually improve the system? So, remember, labels, measurement, feedback loop. And so this is what this system becomes. The system becomes this feedback loop, and I think this feedback loop is actually the more important thing. The internal feedback loop of the system, i.e. it generating code, trying to figure out can it fix the alert, that's cool, that's awesome. You can ship that, you can prototype that, you can get it out. But what this feedback loop is, we have a new prompt refiner agent. And what that can do is it can look at the reviews, it can look at the labels that humans are required to generate as a part of their job, and it can refine the prompt, and they can test the prompt. And so like prompt refinement, context refinement, all of these refinement loops are more important in my mind for these LLMs in production systems than anything else. And so yeah, that's my top. Figure out your tasks to get your feedback loops. Tasks, not jobs. Good feedback loops are the most important thing. They take time. They're actually really hard to do. In most cases, like a label takes more thought than an LLM these days. Bound your scope, set a goal, define success. That's like by far the most important thing. Yeah, appreciate y'all giving me the time. I'm the last speaker, so clap for that. Okay,
absolutely clap. And we have Q&A.
Q&A.
Yeah, we have a good amount of time for Q&A, so fire away. Who's got a question? I'm blinded, so wave your hand maybe.
I'm curious in that workflow, how's the agent, how are you engaging with the agent? Is it a user that is saying, go fix this bug? Are you tagging a GitHub issue? Like, what's the sort of workflow around that?
Yeah, so in the config, in the YAML for the table, there's a table owner. The agent will generate the PR, it'll generate an explanation of the investigation, it'll generate validation just in the description, and then just sets the reviewer as the person that owns the alert. And we have it set up internally so that like when you get a GitHub PR, you're alerted to it.
So it's a test failure in DBT that triggers the
the agent. Right now, the tests are right now. When we build it, the test failure would just generate a Slack comment to be like, "Hey, go check this out." And what you find is like a lot of people don't go check it out, or they have other things to do, and it's not important. And that will bite you 1 out of 10 times because it's actually like an important alert that has like business impact.
I'm familiar with these alerts.
Yeah, somebody in the front is already. I figured I might ask a question for some of us non-developers here of maybe you can speak to some of the aspects where we can understand where these terms of RAG versus MCP versus prompt, how these fit into that upstream aspect of what we're talking about.
Yeah, so RAG is a method to potentially generate information for a user. Let me give an example here. One thing we're going to allow the agent to do, which we don't have, is to look at historical PRs for GitHub for this specific alert. We don't actually do that today. We would RAG that. We would say, okay, look for alerts. Well, it's more of a search, but you could be like, look for alerts for similar ones. MCP, similar to, I think what Hans said, we don't use an MCP here. We just use tools. Yeah, we find that a lot easier for us because we can maintain permissions. We can make them as flexible as we want. So MCP is just a way for LLMs to talk to APIs, or it's like an API layer for LLMs. Yeah, I think that answers your question. Yeah.
Well, first, I really enjoyed your talk. I work in DBT every day, so like felt very seen with this one. It was fantastic.
Glad.
And I also like the bane of my existence is managing permissions in Snowflake. It's literally my least favorite thing. There's 2 people on my team here that will attest to this.
Okay. Okay. I have some people I could set up like a group therapy session with if you're looking
I'm
for that.
in. That sounds great.
Okay.
My question is really on what you think of the SQL that you see the agent generating. Because I occasionally, like once a quarter, go out and test and be like, hey, how good are you at optimizing SQL queries? How good are you at writing? And my experience thus far has been very bad. So I'm just kind of curious, like how you'd score it.
Yeah, that pessimism was my pessimism. First thing that's most important is the feedback loop. So can it write it, see the output, and then test it itself? By far the most important. Giving also the right tools and sort of telling it how to do the investigation is very, very important. Like run these types of commands, run this type of select, look at the schema, do like a show columns in table. Like it's pretty important and you do have to like work with it quite a bit. So like allow it to be able to run, see the output and go, allow it to inspect the schema, and then narrow the context. So like narrow it to that table with that alert. The nice thing, by the way, with DBT alerts is they store the rows that the alerts were on. And so you can also ask it to just like look at those rows and also do an inspection. And it seems to allow it to kind of figure out what the table is because it can like pull in actual rows of data and be like, oh, this is what the output of this table is. And it sort of can then inspect it. We also do have like pretty strict standards on how we write our SQL. So we don't have like subqueries, for example. Yeah, so, and we do pretty good job at naming our columns. Yeah, don't quote me on that. And so, yeah, I think that probably helps a little bit here as well. But I had the same sort of hesitations that you had, and really it was the feedback loop, allowing it to run it internally to test out the queries it was running, that it did pretty well at. Yeah.
Hey, I'm curious to know what problems, if any, you run into with the sort of like directed acyclic graph traversal part of this, right? Like a problem happens in one node and there are theoretically very many nodes upstream. I don't know how much context you need to derive per node. So like, you know, basically is it just a matter of, well, just traverse all the nodes and just chuck it into a thing and it's never been a problem? Or is there some like engineering complexity there?
Yeah, it's a great question. So I showed you a DAG that had like 2 upstream tables to start. That is not our DAGs. It has many upstream tables to start. So one, you give it a tool that allows it to traverse. So like that is very important. Like give it a Python function. We're all in Python, so give it a Python function that can do that traversal for it. It doesn't have to like try to do it. If it tries to, good luck. The second thing is like you do have to give it strategies and recommendations in that traversal. So what I mean by that is like a common thing you see with like rows of null data is a fan out. A fan out, and if you explain a fan out to it, and like a lot of time I would spend is we'd like join 20 tables and I have to be like, oh my God, I have to find which of these 20 tables that fan out is in. And so that was a very important thing. It's be like, okay, here's your rank priority strategy for dealing with nullness alerts. And like, it could be a fan out, and if it's a fan out, I suggest you look at the joins and try to find it there, because most likely, like 9 out of 10 times it's there. And so that narrows the scope for it. But it's right, yeah, if you just give it the unbounded problem, sort of just being like, figure it out, it would be too hard. We also do tell it to like skip to, we call it the staging layer, but like the first layer, because we're like, look, like if you can't find it there, skip to the first, try to see if it's there. On the, like I said, we can get rows of data, so we can get IDs, and then sometimes that allows you, but there are the 5% of cases where it's like somewhere buried in this horrible middle of the DAG.
Awesome, thank you. Sounds interesting.
Yeah.
So in that feedback loop, you have an alert that this row is wrong. How is it testing? Where is it testing that? You know, considering it doesn't necessarily have all the upstream tables and.
So, okay, let me see if I get your question. So we can recompile these tables, we can rebuild these tables. And so we'll rebuild the table, and then we'll rerun the alert. So let's say it's a nullness alert on a specific column. So it's just like a select star, select count from table where X column is null. That's basically all DBT is doing here. So we can rebuild the tables when we make a code change. And DBT, I said it was SQL with Jinja. That's like a slight underselling of it. It also has a graph underneath that allows it to know how to do like linkages between tables. So like that's how it keeps state, because it knows execution order. It'll be like, we have to build this table, and then we have to build this table. And so that's sort of the other thing here. It knows the graph, and so it knows how to parse it. And that was sort of the question over here is like, we will tell the agent with the tool, here's how you build the graph. So you're at table A, we can build the upstream lineage for you. And then that's now context for the LLM.
Hey, Ryan.
Oh, yeah.
So I've actually done a somewhat similar thing, except for I didn't stick it in an agentic framework. I was just like, hey, prompt, try again. Prompt, try again. Like, and I basically would give it like a number of iterations, and I'd find after like 5 iterations, if you let it write some test cases, then solve those test cases, it kind of got there. I'm curious just if you guys went down that road, and if you sort of saw like, hey, if I add the agentic framework, I get like this extra performance, or it's like, I was doing on a very small, simple problem. But I'm curious how much of that boost is from the agent versus test, yes or no, try again.
Yeah, I think the agent provides very little in straight performance. We're a slightly like, RAMP at this point, I don't want to quote the exact number of engineers, but we have like in the hundreds. And what I've seen organizationally is a lot of people doing stuff in local dev. And like, we have local dev AI experts, and then you're like 80% tail, has no idea how AI can be helping them. So like one idea here is you're like, hey guys, here's like a script or a prompt somewhere, and you can go try to use it and like as part of your flow. But then you have that distribution problem of like, you have a new joiner, you're like, here's our like folder of prompts and like strategies. And so for me, I'm always about like, how can we have an agent actually like do a task from beginning to end without the person having to know that that thing exists.
So it's really about the delivery to a bunch of different people on your team quickly in a way that they can just pick it up and run with it.
Exactly, yeah. They don't have to know how the sausage is made. Yeah.
We still have time for questions if anyone has one.
He'll go again.
Yeah, I got you.
Of course you can. Yeah.
So in a few prior answers to questions, it sounded like there was a theme developing, which was that basically like, hey, if you want outcomes that you're not going to be disappointed with, you need to basically be like sufficiently prescriptive and sort of have sufficiently well thought out tools created ahead of time. I'm wondering like if you can give us sort of like, I don't know, like a heuristic sense for like, if you are this level of prescriptive, you can expect to be disappointed, and then we found at about this level of prescriptive, we got value.
It's ambiguous. So here's how I'll try to answer that. I think anytime you're trying to automate a workflow, you have to be really honest with yourself about like how much context you have brought to solve that problem is, I think, the most important thing. Like, does it truly feel like you could throw like a contextless entity that's truly smart and they'll be able to figure it out? Or did you bring a lot of context here into it? I think like, if you went to like even the next thing, which is like fix external API connections for data, that's like a much harder problem because the space of API connections we have is super broad. And you'd have to have a lot of connections on your, like a lot of context on your upstream sources. Testing is a little bit harder there. So like the way I would answer that is just be honest with yourself about like, I think maybe I'll actually reframe it even. Can you write deterministic code to do this? If like you sort of can get there a little bit, it's probably a good problem to try to throw at an LLM and feel like how you do the deterministic thing. Because like a lot of it is deterministic, like fan out investigation is sort of a deterministic process, in my mind at least, a little bit. Yeah.
Cool. Thank you.
All right, that's time.
Thank you so much, Ryan.